Today what we want to do is we want to do what we've been doing in reverse. Okay? And so instead of coming up with the solutions for the polynomials, we are going to give you the solutions and you come up with the polynomial. So look at this one closely. Write an equation for a polynomial with solutions of 4 and I. True or false? False. There can only be one imaginary solution in this situation. False. Imaginary solutions come in pairs. So therefore, if I is a solution, then what else is a solution? Negative I. Both of them are solutions. And the fundamental theorem of algebra told us that everything is factorable to x minus the solution. So x minus 4 would be one factor. What's another factor? X minus I. What's another factor? X minus a negative I, which is x plus I. So that's not written in polynomial form. It's written in factored form. So we're just going to multiply that out. I'm not worried about the x minus 4. That looks familiar. But this looks a little bit strange. So I'm going to start by multiplying that out. I start with the x minus 4. And now I multiply. X times x, x squared. X times I, xi. Something you haven't written before, sir? You'll see what happens. Yep, without a doubt, the middle will go away. So now we move on. Negative I times x is a negative xi. As Kenny just said, they were conjugates, so he knew the middle would cancel. He's absolutely correct. And then negative I times I is negative I squared. So as Kenny said, what happens to the middle? It goes away. All the imaginary pieces will go away. So you can see you have x minus 4 times x squared, what? Plus 1. I squared is negative 1, and then you make it negative due to the negative, so it becomes positive. We good? All right, that's not polynomial form. It's still a factored form, but what's nice is that you do have all of the i's gone. So let's multiply. P of x is equal to x times x squared is x cubed. And x times 1 is x. Negative 4 times x squared is negative 4x squared. And negative 4 times 1 is negative 4. It should be written in descending order. So minus 4x squared plus x minus 4. That is your polynomial. You okay, dude? Sitting in a chair is a dangerous thing. Questions going once, twice, 3 times. Last problem. Write the equation for polynomial. Solution is negative 3. 4 minus 2i roots of 3. Is 4 minus 2i roots of 3 the only imaginary solution? Then you would also have 4 plus 2i roots of 3. You have 2 solutions that are imaginary. They never happen alone. They always happen in pairs. So therefore, you have the following. X what? Plus 3. Now I'm going to be careful here because people often make a mistake. I'm going to write this as x minus the quantity 4 minus 2i roots of 3. And then x minus the quantity 4 plus 2i roots of 3. So do you see how people might get trapped into changing this first subtraction sign to a positive on your second one? And that does not happen. You get x plus 3, and then you have x minus 4, then what? Plus 2i roots of 3 times x minus 4 or plus 4. See how it stays minus 4, but the other one changes to minus 2i roots of 3. So again, people make mistakes with that first subtraction sign. Always, the fundamental theorem of algebra says to write it as x minus, okay? So that's what we would do. I'm not worried about the x plus 3. That's not going to cause me any issues. I am worried about the x minus 4 plus 2i roots of 3 times x minus 4 minus 2i roots of 3. So let's take our time. We multiply x times x. I forgot to write x plus square root x minus 3. My bad. X squared, then x times negative 4, negative 4x. Then x times negative 2i roots of 3 is negative 2xi roots of 3. Which looks really gross, right? But what we've learned is that it will disappear. Everything that has an I will cancel out. We move on to negative 4. Negative 4 times x. And negative 4 times negative 4. And negative 4 times negative 2i roots of 3. Yep. And then the last one, 2i roots of 3 times x is going to be 2xi roots of 3. And 2i roots of 3 times negative 4 is negative 8i roots of 3. And that last one, boy, we better be careful with this last one, huh?
Yeah.
Let's watch how this goes. We have 2i roots of 3 times negative 2i roots of 3. What's 2 times negative 2? So negative 4. What's I times I? I squared, or negative 1. And what's the root of 3 times the root of 3? 3. So that gives you, so 12 goes on the end there. Yeah, what cancels? Yeah, the negative 2xi roots of 3 and the positive 2xi roots of 3. 8i roots of 3, negative 8i roots of 3. And then we have terms that can combine. So we have this x plus 3 that kind of was hanging out over here. And we have x squared. Yep, there's 8x's that we're subtracting. It's 28. Again, we know we're doing it right if the imaginary parts cancel, and they do. Now I multiply out, and I get x times x squared is x cubed minus 8x squared plus 28x plus 3x squared minus 24x. 3 times 28. Well, 3 times 84. Only off by 10. We'll subtract 10 from your paycheck next time. That's close. And so I get x cubed. How about for my x squareds? Minus 5x squared plus 4x plus 84. There it is. That's it. That's the last 4 problems on your assignment from yesterday. You should be set to go. You have almost a half an hour to work.